Hello viewers, welcome back to class. You are welcome to Master Builders Online Academy. I'm super excited because of the way this our lesson is going for year one student who offers objective in their calculus examination. Now guys, if you are new in this channel, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos when we upload it. And don't forget, most of our policy here that you should not skip any part of this video, for this is for your own advantage, so that you will not skip a part or a session in this video that would have helped you gain mastery over this lesson. And secondly, avoid any form of distraction anytime you are set to watch and to learn new concepts from our platform. Then finally, guys, if there be any part in this video you do not understand, maybe when you watch it for the very first time, please, you have the singular opportunity to replay the video over and over again until you get mastery over this lesson. And that is the reason why these lessons are coming in video formats. Now guys, let's get to work. On the board, we are still looking at calculus, differentiation of functions. And now we are in differentiation of what? Implicit functions. Implicit functions. Now, when the relationship between x and y is small, is such a way that you cannot separate x from y or y from x, or make y the subject of the formula, in such case, y is an implicit function of x. Now, when you look at the problems we have solved before this current lesson, you discover that we will always be given that y is equal to, y is equal to, y is equal to, meaning y is always the subject of the formula, and hence y therefore becomes a dependent variable, while x is independent variable. In this case, y is a function, an implicit function of x. Now, when you look at some of the examples that we have here, you will discover that y here is having powers. Y in some cases appear more than once, just like we have in different questions here. So, but for every problem we have solved, maybe when we're looking at direct functions, when we're looking at function of functions, when we're looking at product rule, when we're looking at quotient functions, check those functions. You will discover that y appears once. Y, which is the dependent variable, appears once, and it always appears at the left hand side of the equation. Are you there? But under implicit function, x and y are mixed up. And in fact, y is capable of having any power to any degree. Unlike the first problems we saw, we discovered that the power of y is always 1, y raised to power 1. But in this case of implicit function, you can have y raised to the power of 2, y raised to the power of 3, y raised to the power of 4, y raised to the power of 5, and y raised to the power of infinity. Now listen carefully. What you do in this case is you will differentiate x and you differentiate y function. But listen carefully, we are going to be using shortcut, but I want to first of all explain it in the conventional way. Are you there? So since that we have x and y all mixed up together, what you do is to differentiate the function of x. Now, anytime you differentiate x under implicit function, you pull down the outcome directly. But when you differentiate that function with respect to y, you must multiply the outcome with the y over the x. If, for instance, I differentiate 3x raised to power 2, this will have given me 6x. But if I differentiate 3y raised to the power of 2, this will have given me 6y. Because I differentiated y, I will multiply this result by the y over here. So if I want to solve implicit function using the actual method, not shortcut, I will go to solving these problems in this order. So understand that in implicit function, when you differentiate x, you put down the result that you have. But when you differentiate y, you must put down the result and multiply the result by dy over the x. But if this is understood, then we are good to go. But based on the fact that this lesson is practically made for objective students, now you have to pay close attention. Because I said earlier, if you understand principles, you automatically become a principal. And also, if you understand boundary conditions, you will not overstep your boundaries. So, to be able to maximize the shortcut under this aspect of differentiation, then you need to open your antennas to connect to what network. You need to open your antennas so that you connect to network. Let your signal be active. Are you there? Now listen carefully. So differentiate for every implicit function, dy over dx is equal to minus a function, the derivative of x over the derivative of y. In other words, the numerator will be differentiating the given function with respect to x. And anytime you differentiate with respect to x, listen carefully, anytime you differentiate a function with respect to x, listen carefully, you will consider y as constant. And anytime you want to differentiate with respect to y or y function, you will consider x as constant. This is what this formula will do for us as we solve these problems using the shortcut. Listen carefully. This is derivative with respect to x, and this is derivative with respect to y. So anytime I want to find f of x prime, listen, I must consider that y is constant, like integer, any other number. Similarly, when I want to find f prime of y with respect to y, I will consider all x functions as constants. If this is understood, let's start providing solutions to the very questions that we have before us. Now listen carefully. The problems that we have there may not be enough to gain mastery over this. And that's the reason why we always urge you to seek for other textbooks or consult other authors so that you will be able to get questions from them and learn more. Now we are solving 5 questions each or more each, but you can solve hundreds of problems if you understand these 5 questions that we are about to solve, because the principles are the same. The processes are the same. The methodologies are the same. The approach, they are the same. And that is the reason why when you understand a particular concept, you can use that concept to attack. Yes, to what? Attack any question under that category. And that's the reason why I take my time to always explain to you how to identify different functions. So that when you understand the function, you will know how that particular function is being treated. But I tell you the truth, you can get this with ease right away. Now, let's get to it. On the board, we have a problem. We are asked to find dy over dx from the following functions. And the first function we have, this is our solution. We have the first function. We were given that x squared plus y squared is equal to 25. So you see, when you look at this question now, you discover that y is neither the subject of formula nor x the subject of formula. Y is neither the subject of formula nor x the subject of formula. And you find out that if you want to make y the subject of formula, you're going to have a very complex function. So how do we solve this? Just understand that anytime you have the power of y more than 1, you are dealing with implicit function. Do you take that? Anytime you have the power of x, in any function you are asked to differentiate the power of y more than 1, in any function you are asked to differentiate, understand that you are dealing with implicit function. And how do we deal with implicit function? Now, don't forget that this is practically for objective students, but you can equally learn this. Alright? Now listen, this is dy over dx is equal to minus f prime of x all over f prime of y. Alright, this is it. So now I have that dy over dx. You may not be stating this formula, but all I just want you to know is to know that the numerator is a differential function of x, while the denominator is a differential function of y. Now listen, all I just need to do is to take this equation here, x squared plus y squared is equal to 25. Now, I want to differentiate this function with respect to x only. That means y will be treated the same way I will treat 25. You understand that every time we differentiate constant, we have 0. Is that correct? So if I am differentiating x, y should be taken as constant. In other words, what happens to what 25 will equally happen to y. Since I am differentiating with respect to x, I am taking my time to explain this because I want you to get the basic idea, the concept. So now, I have already made up my mind with what I have just stated here, that I am differentiating this function with respect to x. So if I am differentiating with respect to x, every other functions or variable there are termed constants. And you understand that anytime you differentiate a constant, you have 0. So here now, if I differentiate x squared, I have 2x. If I differentiate y, I have y squared, I have 0. And if I differentiate 25, I only have 0. Because anytime you differentiate constant, you have 0. So my answer here, the numerator would have given us 2x all over. Therefore, the denominator, this is s squared plus y squared is equal to 25. Just listen, it's very simple. Now, I want to differentiate this function with respect to y. Now that I have decided to differentiate this function with respect to y, it therefore shows that x is a constant. And what happens to what 25 as a constant will equally happen to x. So you see that this is very, very simple. So in this case, if I differentiate x squared, I have 0. But if I differentiate y with respect to what I have here, I will have 2y. And if I differentiate constant with respect to y, I have 0. So this will have given us 2y. And the answer to this would have given us 2 takes care of 2. We have minus x over y. This is the answer to this question. Guys, is this very simple? Very, very simple. 2. We have b is s cubed plus y squared plus 3 y cubed also plus 3x y squared is equal to 8. Guys, dy over dx is equal to minus. Now, I know that the numerator is f of x prime. Now listen, if I differentiate this whole function with respect to x, that means all y should be considered constants. All y's should be considered constants. Now, if I differentiate s cubed, this would have given us 3x, reduce the power by 1, 3x raised to power 2. Now, this term contains only y, and if I differentiate y cubed, it will be 0. That's all. Then I come here, you see that this, I have a product of what? 3xy cubed. That means this can be documented as 3y squared multiplied by x. This is the constant. I know that when you differentiate 2x, for instance, now, you have only the constant. If I differentiate 10x, I have just 10. So if 3y squared are constants, that means they happen to now be the coefficient of x. And if I differentiate this constant x, then only the constant will remain. If you understand that if you differentiate 2x, you have 2. If you differentiate n, you have. If you differentiate 10x, you have 10. If you differentiate 100x, you have 100. Then, if you differentiate 3y squared x, you will have 3y squared. Is this taken? If this is taken, guys, I believe you can solve the remaining problems that are here. So, this will have given us plus. So when I differentiate this now, s just appear, I have this. And when I differentiate this guy, I have 0. When I differentiate 8, I have 0. That's all. So when I collect this now, this will have given us 3x squared plus 3y squared. This is the numerator. All over. Now we want to get the denominator. The same way. Now I will state it that I want to differentiate this function with respect to y. I have defined it. Now that means I need to treat x as constant. Now listen. If s is constant, since I'm differentiating with respect to y, this will have given us 0. And if I differentiate y cubed and I'm differentiating with respect to y, then this will have given us 3y raised to the power of 2. Bring down the power, reduce the power by 1. Then plus. Now for this guy, if you are differentiating with respect to y, that means 3x is the coefficient of y squared. And understand that if I have 10y squared, for instance, this will have given me power multiplied by this, and this will give us 20y. Is that correct? That's it. So in this case, if this is 3xy squared and I'm differentiating with respect to 1, that means 3x is constant. And what happened? This power will come down. This will have given us 2 multiplied by 3x y. When you reduce 2 by 1, you have 1. And when I multiply this, this will have given us 6y x y. So here, I will now put down 6x y. Then for the last one, when I differentiate 0, 8, I have 0 being a constant. So what do I have here now? At this point, the denominator would have given us 3y plus 6xy. Simple as this. I would have stopped here because I've gotten my answer. Like I said, 1 or 2, maximum of 2 lines, you will get your answer. Maximum of 2 lines, you get your answer. Now, all we need to do now is to find out now, between this guy, this guy, this guy, this guy, 3 is common. We have 3 here, we have 3 here, we have 3 here, we have 3 here. All I just need to do is to divide each term here by 3, or simply factorize and cancel out. So when I divide, since 3 is a common term to each of these 4 terms here, then I will divide each of these terms by 3. So this will have given us equal to. Now, if I divide this first term by 3, this will give us x here. If I divide this by 3, this will give us y squared. And if I divide the denominator 3y by 3, I have this. And if I divide 6xy by, I will have 2xy. All I just did now to have this result is that I divided each term at the numerator and at the denominator by the common factor, which is 3. And it has reduced it to this. So, guys, this is our final answer to this question. Guys, is implicit function now difficult? Not at all. All you need to know is principles. When you understand principles, you become a principal. No wonder the Bible says, wisdom is the principal thing. Now listen carefully. Now when you understand boundary conditions, you will not overstep your boundaries. Simple as that. Now, let's look at the next question. The next question we have it as question number 6. And we are given s cubed plus y squared plus 2x minus 6y plus 7 is equal to 0. Very, very simple. So what's my answer? The y over the x is equal to negative numerator. And what happened? What's the numerator? Numerator is f prime of x. That is to say, I need to differentiate this function with respect to x. Now, to differentiate this function with respect to x, what do? I need to consider all y functions as constant, since I am differentiating with respect to x. And if that is understood, if I differentiate the first term here, this will have given us 3x, reduce the power by 1. And now this is just y. And when I differentiate constant, I have 0. Plus 0, you can ignore. Alright? Just ignore it, but let me put it down. Then when I differentiate 2x, I have only the constant or the coefficient left. When I differentiate 6y, and this is not, there's no x here, but I'm differentiating this function with respect to x. That means it's 0. Then when I differentiate 7, 0. When I differentiate 0, 0. What do I have at the denominator? At the numerator is negative 3x squared plus 2. All over. Now, I want to get the denominator. So, I will differentiate with respect to y. I have this with respect to y. Now, if I differentiate this function with respect to y, now that I have decided that I am differentiating this whole function with respect to y, then what happens to x? S becomes a constant. Now, so if I differentiate this function with respect to y, and there is no y here, that means this is 0. But if I differentiate this with respect to y, I will have 2y. When you reduce the power by 1, we have 1. So we don't need to introduce that. Then plus, this is 2x. I am differentiating with respect to y, but there is no y there. That means it's a constant. Then that's 0. Then if I differentiate minus 6y, I am differentiating this function with respect to y, and there is y there. That means only the coefficient will remain. That's minus 6. If I differentiate 7 with respect to y, there is no y there, 0. If I differentiate 0, I have 0. So automatically here, I have 2y minus 6. So put down 2y minus 6. This is the answer to this question. You cannot simplify this question further. Why? Because nothing is common between the numerator and the denominator. Nothing is common. But at the denominator, something is common. But nothing is common between the denominator and the numerator. So guys, you stop your solution here. You can decide to open the bracket with the negative sign if you choose to. This will now be negative, and this will also be negative. Alright? These one are in one step. You get your answer. Just one step. Number 4, we are asked to differentiate. We are asked to differentiate 2s cubed y plus x5 minus y cubed plus 10 is equal to 0. They are all the same. I hope you can solve this. But let's solve it together now that I have it on the board. So I want you to go to your textbook and solve more problems. Multiple problems. Are you there? Yes. Now, if that is taken, what do we do here? We just say that the y over the x is equal to negative numerator all over denominator. So how do I get my numerator? I'll simply differentiate this function with respect to x. How do I get my denominator? I'll simply differentiate this function with respect to y. This numerator, this denominator. So if I want to differentiate with respect to x, y is constant. What happens to 10, 15, 20 happens to y. Now, this term contains x and y. That means if I want to rearrange this now, listen carefully. This can be rearranged as 2y s cubed, where 2y are the constant of x or coefficient of x. Like I explained, now that we are differentiating with respect to x, y is constant, which means y is a coefficient of x. And that's what we will just rearrange. Now, if we differentiate x here now, this power comes down to become 3 here, and the power reduced by 1 to become 2. When we multiply this, guys, this will have given us 6 x squared y. I can put that here. 6s squared y. Now, the next term is what? S term also. And I'm differentiating this function with respect to x. So this will have given us what? Plus 5x raised to the power of 4, because it must reduce the power by 1. Now, if this is understood, then the next term is what? Y. And I'm differentiating this function with respect to x. That means this is constant. And if I differentiate y cubed with respect to x, I have 0. If I differentiate 10 without x with respect to x, I have 0. And if I differentiate 0 with respect to x, I have 0. That means this is what I have for f of x prime. Now, if this is understood, let's look at that of with respect to y. Now, if we are differentiating this function with respect to y, that means x will now be taken as constant. Now, if that is the case, at this point, this is the question we have now. This is 3. This one is what? 2 x cubed y. And do you know that we can rearrange this as 2s cubed y? Since we are taking s as constant, and now therefore 2s cubed would have become the coefficient of y, because what happens to 2 happens to x. Both 2 and x, they are being considered as constants since we are differentiating with respect to y. So if I differentiate, if you agree with me that if I differentiate 3y, I have 3. If I differentiate 15y, I have 15. Then if I differentiate 2s cubed y, then I will have 2s cubed. Is that okay? That's it. So I have 2s cubed. Then for the next step, I have this as x. I am differentiating with respect to y, with what I have here. But there is no y in this second term. That means it's 0. I can ignore it. I will come to this one. If I differentiate y cubed minus y cubed, this will have given us minus 3y, reduce the power by 1. Then I have minus 3y squared. If I differentiate 10 with respect to y, since there is no y there, it's constant, that's 0. And if I differentiate 0 with respect to y, I have 0. That is to say the answer to this question is this. Nothing is common. So this is our final answer. One or two lines, you have answer or solution to every implicit function question that you have. Guys, if you have not subscribed to this YouTube channel, your conscience should have been judging you by now. Please subscribe to this YouTube channel if you have not done so, and do ensure that you turn on the post notification bell for more exciting videos when be uploaded. Guys, don't forget to share this video, like this video, and make your necessary comments at the comment section. Very, very important. Now let's look at the very last question, and it's third as question is question number 5e. We have that x plus 2 all squared plus y minus 3 all squared is equal to 25. So dy over dx is equal to negative, create a fraction. Numerator would have been differentiating this function with respect to x, and denominator is differentiating this function with respect to y. As simple as this. Now, guys, how do we have this done? Want to leave that place free? Now, listen carefully. The next thing we are quickly going to do here, there are multiple ways you can solve this problem. But I want to teach you the easiest way to solve this. You see, some people can decide to expand this. You know, when I have x plus 2 all squared, is the same thing as x plus 2 and x plus 2. And when I expand this, I have x squared plus 4x plus 4. Some people can do it this way. Then similarly, you do that of y. But I wouldn't want us to go through this route at all. All you just need to do, identify this question. This question looks like function of a function. Do you remember? This term here. So we are going to be treating this like a function of a function. If I have, for instance, I have u is equal to x plus 2 squared. This is a function of a function. Is that correct? Or y is equal to, this is a function of a function, and you know what to do to this. That's exactly how we are going to solve this problem. So now, it happens that everything inside this bracket is a function of x. Everything inside this bracket is a function of y. That makes this job very easy for us now. If I differentiate this first term with respect to x, listen. This is what we have, x plus 2 squared. Anytime you are differentiating this, what do you have? The first thing you do is to bring down the power. I explained that in function of a function or chain rule, first thing you do, identify the power and identify the function of x. Bring down the power, which is 2, multiply by differentiate the function of x inside the bracket. So if I differentiate x plus 2, I will have 1. When you differentiate x, you have 1. When you differentiate 2, you have 0. So I have multiply by 1, then multiply by repeat the bracket and reduce the power by 1, which this will have given us what? 1. And when we multiply, this will give us 2 into x plus 2. Is this taken? That's it. So I put down 2 into x plus 2. Then the next is, since I am differentiating this whole function with respect to x, and I do not have x here, that means if I differentiate everything here, is 0. And if I differentiate 25, is 0. My answer just becomes this, 4f of s prime. Now the next is what? To differentiate this same function with respect to y, which is fy prime at the denominator. And now, since we are differentiating with respect to y, s will now be considered constant. And when we look at the first bracket, everything there is x. That means this will be 0. We are only going to differentiate this. And to differentiate this, all we simply do, bring down the power, which would have had 2 multiplied by, differentiate what you have inside. When you differentiate y minus 3, you have 1. But when you differentiate y, you have 1. When you differentiate minus 3, that's 0. So 1 minus 0 is 1. So multiply by 1, then multiply by, repeat the whole bracket, and reduce the power by 1. If you reduce 2 by 1, you have it. And at this point, what do we have? We're going to have this as y minus 3. This is it. Then we put down 2 here. Then we have y minus 3. When we differentiate 25 with respect to y, is 0 because there is no y here. So guys, finally 2 takes it of 2. We have this as minus open bracket x times 2 all over y minus 3. This is the answer to this very question. See guys, it is very easy for you to become a master, for you to become outstanding in any course. All you simply need to do is to seek to understand the principles that works. The principles that works. So when you understand principles that works, you become a master. You gain mastery. So guys, the interest or the aim of this lesson is to help you become mentally sound when it comes to calculus. Alright, so if you have not subscribed, at this point, if you have not subscribed to this YouTube channel, please do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos when being uploaded. We love you guys. Thank you for watching. As usual, you can check the description below where you will find the link to the next lesson. Don't forget to share this video, like this video, and make your necessary comments. See you guys in